the difference L minus LO is delta LBT. From the triangle, the triangle is like this and of the 1P and on the beam will move down like this. It's not like this.
This is rubber.
It will rotate like this. That's not. So the distance for CE is 10 millimeter. How to find the distance data LBD? We can find data from the triangle. Because data LBD over 3, data LBD over 3 must equal data LCE over 7. The length is 7. 2 plus 2 plus 3 is 7. So we can get it is 4,286. Right. So from the formula we can get the long string of PV. Another example, how to find the share string. Share string. Look at the problem. The plate shown in the figure is fixed connected along AB and hold in the horizontal growth at its top and the bottom. AB and BC. It means AB can't move. It's fixed on the wall. On the wall. The direction of AD and BC is always horizontal. So, if its grand set CD, grand set CD is given uniform horizontal displacement of 2 millimeter, determine the average normal string along the external AC and the share string at E relative to X and Y X. BC BTR determine the average normal string along AC. So according to the formula, at first we have get the length of the deformation and the length before deformation. Yes, now.
Yes.
The length BC, how much?
115 millimeters.
AC is AC. Yes, now. Is AC.
AC before deformation. After.
Is it easy for you?
Yes. This square plus this square.
Yes, sir. AC brand.
What does this mean?
AC brand. AC brand. Yes or no?
What do you say yes to? AC prime.
AC prime means after deformation.
Yeah, after deformation. The length of AC.
150 plus 2.
AC is L0 and AC prime is
So the average is the normal string from the according to the formula is here. The share string is more difficult. At first, we know AC and BD at the point in the E, AC perpendicular BD. Yes or no? We have find the tangent half theta is 76 over 75. Yes or no? Downward.
The first note is the question.
E.
Yeah. Yeah.
Of the theta is the figure is of the deformation. So is 76 is 75. So tangent half theta is 76 over 75. So we can find the theta is more than 90 degree. Yes or no? So gamma x y, the shear strain is half pi minus the angle of the deformation. So is minus. Answer that. In this we will find the shear strain. Okay. By experiment, we find what by experiment we know for a given model we know sigma is yes or no?
Yeah.
We can also find we define E is normal stress. Because we call it Young's modulus.
Module.
Young's modulus. Yeah. We can also introduce shear strain models. Shear models of elasticity is shear stress over shear strain. In elastic region, we know shear stress over shear strain is uniform, is a constant. So we can get the formula. We call it G, and G is the shear modulus elasticity. Shear strain. We call it Hooke's law for shear stress. Hooke's law. Sigma equal E 高嘛，we call it Hawk's law. Hawk's law. In this way, we finish the chapter. Okay. Let's move to chapter 8. In chapter 8, we are going to introduce the mechanical properties of materials. It's easy. What is the property of the materials? We can also call it it is the relationship of stress and strain.
Stress and strain.
Yes. Mechanical property of materials depends on the relationship between stress and strain. We have to how to find the mechanical properties of materials. We just can get it by test. We make a specimen. We get a specimen made of a given material. Suppose it's steel, yes or no? Suppose the material is steel. How to find the mechanical properties of steel? At first, we made a specimen. It's use steel. We made a specimen and put it on the machine. On the machine. Then we can load it. Tension or compression test. We can get a curve. We can get a curve at the first time. At the first time, when the specimen is in tension, at the first time, the force, the loading is increased. The specimen is getting longer. When the specimen getting longer, we can get the stream normal. We can get the normal stream at any moment. we can also get this stress at a given moment. We find the stress divided by the strain is a straight line. We call it elastic region. At the first time, the loading, we exerting the loading gradually. At this point, the loading is zero. When the loading is getting more later, the deformation is getting longer, a little more longer. After the loading reaches to the point, the line is a straight line. We call the stress is a proportional limit. After the stress come to this point, if you remove the loading, the specimen, the deformation in the specimen will disappear. If the stress is more than this stress, if you remove the loading, the deformation, just the part of the deformation disappear. There are another part of the deformation don't disappear. Remain in the specimen. We call that is yielding. Understand? When the loading is continue to increase, the deformation will increase. In this region, we call it strain hardening. When the stress come to sigma U is ultimate stress. The space where this formula will appear. We call it lightning. Then when the stress comes to the point, the specimen break. So we have to know this conception. The first part is elastic region. The second part is the yielding region. The third part is strain hardening. What is a proportional limiter? What is a yielding limiter? What is elastic limiter? We have to know this kind of conception. Because for the beam, in the spin there are steel rod. In the beam, there are steel rod. When the beam is working, the stress in the steel, the normal stress in the steel can't more than elastic limit. It must be less than elastic limit. If it is more than elastic limit, we call it failure.
Failure.
Yeah. If the stress, if the normal stress in the steel rod is more than elastic stress, we call
Failure.
it failure because the deformation is too large. Well, not too large. We will fail is not safety. Yeah. So we have to know this kind of this conception. What is elastic? What is yarding? What is string holding? What is lacking? What is proportional elastic limit? What is ultimate stress? It's great. We can find the stress when it is break. This stress is ultimate stress. Yes or not?
What about the fracture stress?
What?
The fracture stress.
Fracture stress.
Yes.
Yes, fracture.
It's broken.
Fracture stress is ultimate stress. Yes or? It's a curve. It's a curve to express the property of a material. We know this region is a string holding. In this region, at a given point, when you remove the loading gradually, the strain and the strain divided by stress will be constant. So there is also a straight line. After you remove your loading, there are a deformation. We call it a plastic strain. As that, it means suppose it's a steel rod. We exerting load on it, it will be getting longer. If it is come to string holding region, after you remove the loading, the rod will be longer than the original length. Understand?
Yes.
But at this point, if you exert loading it again, it will increase along this line. So the elastic limit is more than the original one. Understand? For the original rod, steel rod, the elastic limit is here. Of the steel is loading in the string holding region. The elastic limit is here. So the elastic limit increased. Improved, yes sir?
Yeah.
Increased. Is increased. So in some cases, if you in practice, if you want to save steel, because when you make a beam, the concrete is cheaper. The steel is expensive. That's not. Suppose for a beam, they have 4 steel. There are 4 steel. As
Yes.
we have arranged 4 steel, because the steel, the stress in the steel can be more than elastic stress. So if you at the first time, there is in practice, suppose is a steel, we exert the force on it, it will be getting longer. It will get longer. Yes,
Yes.
if in the steel there is a plastic string, if there is a plastic string, the steel, the elastic limit of the steel is increased. So maybe we can sew one steel, maybe 3 steel, maybe 3 steels is enough. Understand? Understand? So is important. Is important. We just need to know this concept. Plate, material, and ductile material, there are 2 conceptions. If the deformation is like this. The definition is like this. For a rod, we exert loading on it until it's break, and but the length is more than the original length. Is not. Is the length of the break of the break is the length before deformation is the original length divided by original length. If it's less than 5%, we call it brittle material. If it is more than 5%, we call it ductile material.
More than 5%.
Yeah,
Okay.
ductile material.
So wood is not ductile material.
So what?
Wood.
Wood?
Wood is ductile material.
I don't know. I'm not sure. Of the experiment, we can know it. Understand? For the steel is the ductile material.
Steel.
Steel is
Ductile.
yeah low carbon
That's
steel
why all
is ductile
all
material.
metal are ductile material.
Maybe high carbon steel is brittle
Yes.
material.
Snap.
How to determine it? We have to determine it by experiment.
Yeah. This
How?
is not ductile material.
It's a brittle material.
Yeah. Yeah, this is
Brittle.
not ductile.
Eh? Eh? The length is L. Is original length divided by original length.
I think this is same.
Yeah, maybe same.
Same. But if you break a steel rod,
Not
the
same.
here, the length will
It's
be
not the same.
different. So
Must
it's
be a little longer.
yeah,
A
that
little
is
longer.
not
So it's
ductile.
brittle.
Yeah.
Okay. What is the ratio? What is the ratio? What is the ratio? Is a rod. Is a rod. For the rod, when the rod is longer, the transverse direction will seen, is it not? When the force P is applied to a ball, it changes the ball length by an amount data and radius by amount data prime. It's longer. Epicenter is normal strain in axial direction. Is the normal strain in lateral direction. The ratio. The ratio.
What is the ratio?
The ratio of the two normal strain is a constant. We call it positions ratio. So it's difficult. We don't know. Okay, this is chapter 8. In chapter 8, I just introduce some conception. What is elastic? What is reality. What is elastic limitation?
Just definition.
Elastic limitation stress, proportional limit stress, ultimate stress. What is duct material? What is brittle material? What is poison ratio? Just introduce conception. For absoluting in chapter 7, I introduced how to find the stress we know. Yes. In chapter 9, I will introduce how to find the deformation for absoluting. Objectives is to determine deformation of absolute member, to determine support reaction. When this reaction can be determined use statics. To analyze the effect of thermal stresses. Deformation. At first, let me introduce the deformation of an axial loading plot. BC is axial loading. 1P acting on the rod because we know Hawkins law. Hawkins law. So sigma is P over A.
Yes.
Yes or no?
Yes.
So because sigma is theta over L. Theta is the difference between the length of the deformation before deformation. So we can find the data is replace epsilon by data over L. We can find the data is B over AB. E is a formula to find the elongation of an absolute body. This is the formula. Is a example. Each segment for the rod, the internal force of difference is not so. The elongation of the rod is the summation of each segment. Same configuration. If the body is in tension, is positive. Compression is negative. So I give you an example. Give you a problem. Is homework Yes.
Homeworks.
a circle rod. Radius. Radius. Find the elongation. 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 Find the elongation of the rod. Use you can according to the there is example because I have no time. Because I have no time. So I didn't show you an example. You have to do it. You have to do it by yourself. Okay. You have my PPT. You after you read the PPT, you can solve.
This is
Yeah, same.
Let me just.
It's a drop.
No, I have the picture, but I just want to know what it is.
You have the
Yes, I want to know.
Okay. That's all for today.
Oh, that's good. And is it necklace?
Which one? For the board, what to find the sales address R equal F over A over A is by R square. Variance variance yes is F A variance and is is the homework is fine. Most of you because most of you are right for the homework this time.
Yes.
So you know the data.
No, I think let's go through again.
Yeah.
Just go through.
Just
Do you want to just go through? Because some people might have questions.
it's break and check it. You don't know?
I know, but then I'm saying some other people might have questions.
No. I check the homework.
Okay.
All of you
Get good marks.
are right. So I don't repeat it. Okay?
Yes.
Today we are going to study the deformation for axial loading. Further.
deformations.
Yeah. Is Edison loading rod applied load tends to change the body's shape and the size, referred to as deformation. Of the loading applied. The specimen will elongation longer. How to describe the deformation? We use string. String is defined. String is defined as the for a given body, when after the loading at it, the value it will be changed. The length will be changed. Before change is a straight line, is a curve. So how to express the deformation is important. At first, we introduce a new conception, normal string. Normal string is defined as a measure of elongation or contraction of a small length segment in the body. Average normal string is L2 minus L4. LO is the original length. L2 is the length of the deformation. The difference over LO is the average normal string. And for a rod, is a rod. We draw two lines on the specimen. Is L O length is L O. We often applied. It will be changed. It will change. Longer. It will be too longer. So, normal string average is defined as L2 L4 over L4.
What is the name of this symbol?
What?
This symbol.
Everything. It's the average normal situation. One LO close to zero, it is normal situation. It is a normal situation. The volume, when the force acting on the body, the volume is changed. The shape also change. How to express the change of the shape? We introduce another string. We call it shell string. Shell string. Shell string. How to define the shell string? At first, it's a given part of the force acting on it. The shape will change. At a given point, we draw two straight lines. We draw two straight lines. They perpendicular each other. Of the shape change, the angle will change. The angle will change. The degrees, shell string is a measure of the change in angle that occurs between two small length segments that are originally perpendicular to one another. Decrease in angle result in positive shell string. Increase is negative. It means for a given button, at a given point, suppose it's A, we draw two lines. The angle formed by the two lines is 90. It's 90. Then some force acts on it. The body, the value, and the shape are changed. So the two lines will be changed. Yes, the angle is not 90 degree now. So, how to describe the deformation of the shape? We introduce shell string. Shell string is gamma. We call it gamma. Denoted by gamma is half pi minus theta prime. Is theta prime.
No shit.
Theta prime.
Before deformation.
Before deformation, the angle is 90.
Be 90.
Always.
Yes. Always. Yes. Shell string and the normal string can describe the deformation of a body.
I wanted to ask, since you're saying the lines, the angle between the lines is always 90, then I wanted to ask where these lines, like any lines?
Yeah, the line is depend on yourself.
Okay.
You can draw the line, I can draw the line like this, in this direction. I can also in this direction. The different direction, we can get different shell string. Just shell string. It means, suppose for cube, it's a cube. That's for cube. Add 1 point. Add 1 point. Each of the there are three surfaces. There's the three surfaces 1 and 2, 3. There are three surfaces. The line perpendicular each other is but after some force added on it, maybe it change like this. Is
Yes.
it will maybe the shape will be changed like this. So this for this plane, the shear stress is decrease in positive shear strain. Yes, not. Is is increased because the angle is more than 90 degrees. So for the plane, it means in this plane, in this surface, the shear strain is negative. But for this degree, it's less than 90. So on this surface, the shear strain is positive. Understand?
Yes.
So for given point, the line is dependent on yourself. Different direction, the shear strain are different. For given point, there are three shear strain because there are three different directions. There are also have three normal strain because there are x direction, y direction, z direction. For given point, if you know these three different shear strain and three normal strain, we can get an arbitrary direction. For any arbitrary direction, we can get the shear strain and the normal strain. It means it's a given body. Yes, is a given body. Is a given body. At a given point, suppose it's A, we get a cube. We get a cube around the point A. If we know the three different shear strain and the three different normal strain, because it's x direction, z is x direction, y direction, z direction. This direction will have epsilon y, this direction epsilon x. In this direction we have epsilon z. For the surface we have gamma z y this angle is gamma x y. So this angle is gamma x z. Yes or no? There are 6 strings. If we get the 6th string and point A, we can get suppose there is a direction. Yes or no? How much is the normal string in alpha direction? In the future, we will know how to find it. If you know the sixth string, we can get any. We can get the normal string in every direction. Understand?
Yes.
We will learn it in the future. We can also find the shell. We can get the shell string in any other surface. It means suppose after you know the sixth, string, we can get suppose it's a plane. It's a plane. It's not. It's a plane. It's also plane. We can get the shell string. Also can get the shell string in this direction. In any other direction, we can find the shell string and normal string. Often we get the 0, 3 shell string and the 3 normal string. String is dimensionless because shell string is an angle. Normal string is a ratio. Yes, suppose the unit is a meter. Is a meter. Meter is divided by meter, so there is no unit. Shell string because angle for angle there is no unit. So string is dimensionless.
How do you measure that angle that is made after deformation?
How to get the angle?
No, how do you measure the angle? Like if
How to your attention?
no, like
It's a challenging problem.
it's a challenging problem.
Yeah, because we don't know. There are some true and suppose is a bottom. Yes or not? Suppose is a bottom. For example, the bin. How to find the string? We have some tool. We call it string some of the materials, the physical, well, the physical, how to express it? The physical resultant will be changed. You can, yeah. We use some tool. Huh? He asked me a question, but he.
I have understood, Lord. I'm understanding that you use an instrument that is, you don't really know how to explain it, but it's called like a physical. Yes.
We have some tool. When we want to find the string, I don't know how to call it in English. We put some small tools which glue on the surface of the member. When the body deformation, huh? 应变片。OK， 哎，有啊，累的呗。哦，这里没有。没有。那等，OK， 看是在哪里啊？
I think it's a meter.
You put a meter?
Yeah.
You call it a meter?
Meter. Yes. Yes.
Yeah. Your brother goes this way.
String reset
所以我
有其次。If we want to find this string, and if we want to find this string, we can put some tool on the surface of the body of the shape of the deformation of the deformation. The physical property will change. We can get this change per meter. They are land because the electric will change. And
What?
electric resistance string goes.
What about in theory? Like in a case where if we're given a
What
question,
is the one? What the?
like what about in theory, like when we're learning in class, we obviously can't get the gauge and try to find the if you've given us a question, let's say find the shear strain. We've been given a question and we know that an object or a member that hasn't been deformed is at 90 degrees at a certain point at any given
No,
time.
not
That's
at
not
any-
what you said.
It means if we know the normal strain in the speed direction, we can use the theory to find the shear strain. That's that. There are some formula. There are some formula to find the shear strain. Because shear strain we can't get it by experiment. Understand? We can't get it by experiment. We just can get normal strain. And there are three cases. 1, 2, 3 direction. 1, 2, 3 direction. 1, 2, 3 direction. It means if you know for a given point, if you know the three direction, normal strain, we can find the shear strain by formula. It's a strain. Strain is more difficult than stress. Yeah, strain got. Is an example how to find the strain. A thin strip of rubber has a strength length of 15 inches. If it is stretched around the pipe, have another old diameter of
5 inches. Determine the aboriginal strain of the strip.
yeah. It means the original length is 15 inches. Is the length of the deformation. Yes or no? It means suppose is a pipe, a rubber rounded, yes or no? Rounded. The length is pi times 5 for secant. Yes, sir.
Please say that again.
Say it again.
Yeah.
So it's a bag. It's a rubber. Like this lah.
Yes.
Yes, sir. The original length is this. It means it's shorter than the. Yes, we have to force it longer around it. So it's 15. The original length is 15 inch. Of the deformation, the length is pi times 5. So the normal strain for the rubber is this. It's not.
Yes.
It's simple. It's very simple. Here is the other example. Read the problem.
Teacher, can you see the formula again?
Yeah, no.
Because the previous one, can you see the
Sedona.
Can you see the formula again?
Formula again. You can remember the formula. It's the formula. The rigid beam is a rigid beam. It means for rigid beam, it can the deformation. Rigid body, it means it can the deformation. The rigid beam is supported by a pin at A and the wells BD and CD. If the load P on the beam cause the end state to be displaced 10 mm downward, determine the normal strain developed in well CD and BD. It means from the figure we know the original length is 4 meters. That's not. The elongation is 10 millimeter. So it's 10 millimeter divided by original length. Yeah, it means L minus L is 10 millimeter. It's 4 millimeter. It is 4 times millimeter. So we can get the normal strain. For dB, because is 10 millimeter, so we can find the length by the similar triangle law. Yes or no? Right. Theta BD over 3 equal theta LCE over 7. What? Read that.
Erased.
Okay. Tell you follow.